Hello and welcome to our discussion of the identification of metamorphic rocks. Additional videos have been provided for sedimentary rocks as well as igneous rocks. In this case, metamorphic rocks are rocks that have formed from any of the three main kinds or classification of rocks and have been subjected to heat, pressure, and different kinds of stresses. This areas where this is most likely to occur include places like subduction zones where the crustal stresses and heat flow are high. There are two main types of rocks that we're interested in. First, we have foliated rocks, and as you may have guessed now after listening to igneous and sedimentary lectures, the two key features are texture and composition. The second type or broad classification of metamorphic rocks are non-foliated rocks. And I'll go through and define what a foliation is. A foliation is an alignment of minerals in a rock. As stresses, shown by these vectors here, are applied to a rock, especially when it's under higher degrees or increased temperature, we'll find that we'll get minerals that will grow or grow in alignment with one another in response to the subjecting the rock to stress. This particular alignment shown here is called a metamorphic foliation. If the rock contains no alignment, so we might come up here to the top box like this, where the rabbit is, there's no stress there, so we're not going to get a foliation. We're just going to get coarsening of grains as we subject the rock to higher temperatures, and that's a non-foliated rock. Here is our example of foliated rocks, starting with the finest grain size, which is slate. You cannot see grains. You can see the layers in the rock here, especially if you turn the rock on its side. That's best in this case. And if we jump to the right, we move up in grain size. What happens when the grains get larger is that we get more reflective surfaces. And you can see that here and here to some degree. You also tend to get ripples in the surface of the rock, and then you will also see layers along the edges. Both slate and phyllite are fine-grained, with slate being very fine and phyllite being fine. Schist is the next rock in terms of grain size, is foliated again. This particular rock has grains that are giving off a shine or a sheen to them that you can see in this area here. Okay. And so you're starting to see grains pop out at you. In this case, you see these red blobs. Those are what we call porphyroblasts. Those are minerals that grew as the rock was undergoing a subjection to heat, higher pressures and temperatures. They grew in the rock. And again, it's one of those types of textures that is a coarse grain with a finer grain matrix. If we crank up the pressures and temperatures even further, higher temperatures, we'll start to see individual grains of the white mineral here, which might be plagioclase, or gray mineral, which might be quartz, like up here, separating into different colored bands. Those bands are and the rock is becoming very coarse, easy to see individual grains here. Those bands are indicative of a rock we call a gneiss. Okay. Here's another variation on some of these rocks that are foliated. Here's our slate. Here's a schist here. And then you get banding for our gneiss on the right-hand side. I did not put a phyllite in here. What do these represent? Well, they represent the smallest grain sizes at the lowest pressures and the lowest temperatures. As you increase pressure and temperature, in particular increasing temperature, you see grain size gets larger. Okay. And the foliation becomes coarser, moving from fine layers to very clear light and dark colored bands. Where do foliated and non-foliated rocks form? Well, contact metamorphism is primarily responsible for non-foliated rocks, as we're going to discuss them in this class. In this case, we have a hot body of magma, the Anawa Pluton, sorry about that, here, which is intruded into the rocks, and it is conducting heat out into the rocks around it. Okay. The gray rock out here, or brown, is already a slate, which means it has a foliation. But the heat from the Pluton is recrystallizing the rocks immediately around the Pluton, and those grains are growing larger. But because there's no stresses on those grains, they're not becoming aligned. So the rocks we expect here are non-foliated. Okay. What kind of rocks do we see in our box? Typically, non-foliated rocks are going to be one of two compositions. The first is going to be quartzite. Okay? And a rock made entirely of quartzite will have many of the properties of quartz. It should be harder than glass, which means you can scratch it on the streak plate, and it will be non-reactive. Okay? Marble is another alternative. It can look identical to quartzite. So the key with marble, you can see no layers in here, so it's not foliated, is to scratch it, and you should be able to not scratch glass. Also, marble is made out of CaCO3 or calcite, and it will react with hydrochloric acid. One of the things we're interested in then, as well as identifying the rock texture, which is foliated or non-foliated, as well as its minerals and composition, is the parent rock. For foliated rocks, the parent rock will always be some kind of mud or mica-rich, clay-rich rock, mudstone, shale. All those are required to grow in alignment to create a foliated rock. For this particular class, we're focusing mainly on marble and quartzite. And so quartzite is formed from, as you might guess, quartz-rich sandstone. It is fairly non-reactive, so that means the quartz grains just grow together. They don't actually form new minerals, whereas in a foliated rock, you're commonly forming new minerals. Marble is very similar to quartzite. It's non-reactive in the sense that it will just simply grow larger minerals, and its origin is from a sedimentary rock called limestone. If we jump to our chart for identification, and I'll start on the right-hand side, you'll notice here's our group for foliated. I'm going to go ahead and erase that and draw it one more time. We'll just do our group here for foliated, and then for non-foliated down here. There's a bunch of rocks that you don't have in your kit. So we don't have faultbreccia, we don't have serpentinite, and we don't have hornfells. We don't have metaconglomerate. You can skip that as well. Okay, and we may have coal, though, which I didn't show you an example of, which has a protolith or a parent rock here, a bituminous coal. So coal just gets refined through the metamorphic process. The first step is to identify whether or not it has, I'm moving left here to the table, whether or not it has a foliated or non-foliated texture. You can then identify or describe the grain sizes, very fine, fine, medium, or coarse. And then, if possible, we'll label the minerals that are present and then the rock name. So if it's foliated, once you know the grain size, that tells you the rock name and potentially the protolith. Okay? So that's easy. If it's non-foliated, we only have really three possibilities, and you need to test the composition of those. Marble reacts with HCl, does not scratch glass. Quartz does not react with HCl and will scratch glass. And then bituminous coal, actually many of its characteristics are given over to anthracite. So you'd expect something that's black, shiny, conchoidal fracture, and so on. This concludes our discussion of the identification of metamorphic rocks. I highly recommend that you see or view some of my short videos on metamorphic rocks, taking the names from some of the rock names on the right here, slate, phyllite. All these will be labeled and presented, and it will give you a sense of how to go about actually identifying the rock.